In this problem, a six-sided die is rolled twice. We want to look at finding some counts and probabilities as related to some events to get us started at thinking of probability. First of all, we're asked for n of omega, which this is the total number of outcomes we could have in our experiment or process. So since we're going to be dealing with the dice problem for a little bit here, the easiest thing to think about is making a grid. We could have our roll 1 and our roll 2, and we have all the options for roll 1 of 1, 2, 3, 4, 5, and 6, and then all the options for roll 2, 1, 2, 3, 4, 5, or 6. So this would represent like rolling a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, and so on. 1 and a 5, 1 and a 6. Then we have 2, 1, 2, then a 2, 2, then a 3, and you could fill out the rest of this. So notice if we count the total number here, we've got 6 options on the first roll times 6 options on the second roll, so a total of 36 possibilities. In part B, we're asked for n of A, where A is the event that the sum of the two rolls is a 5. So if you would go through and look here at which things make A true, A will contain the rolls of a 1 with a 4, those add up to 5, and then the reverse, 4 and a 1, a 3 and a 2, and a 2 and a 3. So those are the 4 possibilities from our 36. So the number of things in A is 4. In C, we're asked for the probability of B, where B is the event that the two rolls are the same. In order to have the two rolls the same, we could have a 1, 1, we could have a 2, 2, we could have a 3, 3, a 4, 4, a 5, 5, or a 6, 6. So these from our grid would be these on the diagonal here. So the number of events in B is 6, and we can get the probability of B by taking the number of events in B out of the total number of possible, not events, but outcomes, total number of possible outcomes. So we end up with 6 out of 36, or you could reduce that down if you want to a sixth. We're also asked on the probability of C, where it's that the sum of the two rolls is even. I'm actually not going to write out all of the things in C, because if we look at our grid here, where do we have the sum being even? Here they're even, these add up to 4, these add up to 6, these add up to 4, and so on. So what's going to happen is we're going to pick off every other one here. And so the probability of C is going to be that there are 18 outcomes that add up to an even number out of 36, or probability of a half or 0.5. And then probability of D is that the two rolls are not the same. The easiest way to think of this one, to find the probability of D, is to do 1 minus the probability of D complement, or that D does not happen. And so what is the probability of D complement? If D is that they are not the same, then D complement means that they are the same. D complement is are the same. And we already said that the probability that the two rolls are the same is 1 out of 6. So the probability they are not the same is the leftover probability, which would be 5 out of 6.